それでははじめにノルウェー国立公衆衛生研究所研究担当理事のパー・マグヌス先生よりご講演いただきます。パー・マグヌス先生は1998年よりノルウェー母子コホート調査の主任研究者として非常にたくさんの成果を発表されておられます。それではパー・マグヌス先生、どうぞよろしくお願いいたします。
Dear everybody, thank you for the introduction. It's a great honor for me to be invited to Japan and to be part of the scientific advisory board for this study. And I want to congratulate you with what you have achieved so far. I am very impressed, and I encourage the Japanese government and the Japanese public to continue to support this study and even expand it with scientific questions and with longer follow-up. My task now is to talk a little bit about a study we have done and are still continuing with in Norway, the Norwegian Mother and Child Cohort Study. This has a very broad aim to find causes of disease, not only environmental exposures, but everything you can think of. It's a pregnancy cohort, and it's built up as a family cohort, so we want to include the mother, the father, and the child. And we have a long-term follow-up. There is no date of ending this study. It's based on collaboration with 50 hospitals. The pregnant women were recruited in the second trimester, about week 17, from a large number of hospitals all over Norway. It is based on informed consent that says that we can study causes of disease, we can study genetic factors, environmental factors. But if you don't like to be part of the study, you can withdraw at any point. And the mother consents for herself and the child, and the father also gives a separate consent. And we try to inform the participants, and the child is directly informed at the age of 15, and the oldest child is now 16. And we will have the consent of the child at 18 years, and we hope that that will be an opt-out possibility after information. So you can see there is a total number of about 95,000 mothers included, who have contributed 113,000 pregnancies. And then you understand that many mothers, 18,000 of these pregnancies are mothers who gave birth to more than one child, had more than one pregnancy during the recruitment period, which lasted for 10 years. And so there's 75,000 fathers and many twin pairs. And having these siblings and twins means that we can have some very interesting designs where we can look at contrasts between siblings. And the data collection begins with biological material from the mother, blood and urine sample, and a blood sample from the father. And then there are questionnaires, and there are also repeated blood sampling from the mother and child at birth or right after birth. And then we continue with questionnaires. And you can see there's, when the child is about 7, we collect the primary, at least we try to get one tooth from each child, and the intention of that is to study environmental exposures from the fetal period. things like heavy metals. And then we continue with questionnaires. And the fathers are important, but we have sent the questionnaires to the mother up to now, but we are now presently, actually now in December, sending a second questionnaire to all fathers. So we are interested in the father's own health. We are interested in the chronic diseases of the parents. And we are, of course, interested in the father's relationship to the child. And we are now starting with web-based questionnaires to the children regarding behavior, mental health, but also regarding nutrition. It's a big biobank, and we have taken care of whole blood plasma, and we have extracted DNA from fresh blood as they arrived to the biobank, which means that it's available for genetic analysis very readily. We have also taken RNA samples. And these blood samples and urine samples are, of course, important for what you are thinking about here in Japan, environmental toxicants and contaminants. But they are also used for genetic information and keep track of infections and dietary factors, exposure measures, medications, and also early signs of disease development. In a sub-study called Harvest, we have now done a GWAS, or genome-wide association study, meaning we are looking at a large number of marker genes in 11,000 trios, mother, father, and child. And in a small part, 1,000 trios, we are also doing a environmental biomonitoring study. So this Harvest is based on an Illumina chip, which is just a technique to do genetic analysis. So it's a large number of single genes or parts of genes, which can help us understand both the genetics of disease, but also the gene-environment interactions. And I think a lot of things have been done internationally as regards the association between single genes and disease. But they have usually been done without looking at the environment. And I think what your Japanese study, together with the Danish and Norwegian, can really help us with is to understand how genes are important for susceptibility to disease and for the sensitivity to the environmental hazards. So with having these very rich exposure cohorts with a lot of environmental data, together with genes, I think we will move forward. And this is often called personalized medicine or precision medicine. And I think we can talk about precision prevention. It's at least important to understand that there are some groups in the population that are maybe more sensitive than others. So for the biomonitoring, we are doing a lot of assays, as you can see here, and I think this is only part of it. So we would like to collaborate with you and others on these biomonitoring issues, which is important to understand exposure levels in populations. So it will be very interesting to compare Japan with Norway. What we have in the Scandinavian countries is a unique personal identification number for every citizen. And we have health data that is gathered in registries, so we can link the cohort to a lot of endpoints. So even though we have not a very, it's not like in Japan. I saw you had a very high follow-up rate, more than 80%. In Norway, it is going a little bit down, but for the endpoints, we have the registries and also some exposure registries like the vaccination registry. So this is very important for our cohort. So as I mentioned, the strength of this study is I think the family design, the large number, and the enormous amount of data on exposures, and again the combination of genes and environment. We have very active researchers in Norway and internationally. There's about 200 sub-projects, and some of them are finished, or many others are finished. And we have some large sub-cohorts where you collect additional data, for instance, in neurodevelopmental disorders, where we also collect more biological material. So there's a lot of publications and PhD students. And I'm not going to go into detail, but there's a lot. These are just a list of research areas that we have been working with. A lot of them in the pregnancy period, and now a lot of them in child health. And now we are moving on to the teenage period and to the adulthood. And we are interested in the parents too. This study is only partly funded by the Norwegian government. Actually, it wasn't really funded at all in the beginning, but we have had the Ministry of Health and the Ministry of Education, but strangely enough, not the Ministry of Environment in Norway has not funded this study. I hope they will become interested. But we had important contributions from the National Institutes of Health in the United States, and also from the EU research framework programs. Very quickly, a couple of findings. We have found some evidence that folate supplementation in the very early weeks seems to reduce the risk of autism and severe language delay. This is still to be replicated. Another thing, intake of paracetamol in pregnancy and child neurodevelopment seems to be an increased risk if there is a long-term use of paracetamol during pregnancy. Again, this must be confirmed by others. But also, I think an important thing about these cohorts is that there is a lot of anxiety among people about the risk of disease with environmental exposures. So these cohorts can contribute to reducing the anxiety by our findings that there are no adverse health effects. For instance, there's been worries in Norway at least about the use of cell phones and the use of antidepressants as two examples. So we can say, well, it doesn't seem to be very dangerous. So this is the website, and I look forward to have international collaboration, and particularly with the Japanese study. Thank you very much.